Hello, welcome to Gaffer's Grinds. In this video, we're going to do a walkthrough of some typical questions about the titration number 2 on the course. Now, in this titration, you were trying to figure out the concentration of ethanoic acid in vinegar. The acid is in vinegar, and we're trying to find its concentration. Therefore, it must be unknown. So that's the important thing to notice. Right, in this titration, vinegar is diluted as it's too concentrated. Right, why should we dilute vinegar? Well, if we use the original vinegar, we'll end up getting a titration value of, say, something like 1.5 cm cubed. Now, during titration, everyone can make an error where they don't stop at exact endpoint. So let's say you stopping at the endpoint, but you're approximately maybe 0.1 centimeters cubed out. 0.1 centimeters cubed out of 1.5 is quite a big error. All right, it's about 7-8%. So 0.1 out of 1.5 is about 7-8%. Whereas if you have a titration value of 30 cm cubed and you're making a 0.1 cm cubed error, so you're out by that much, this is a much tinier error. So 0.1 is a much smaller percentage of 30 cm cubed than it is of 1.5 centimeter cubed. And that's why we always want to use solutions where we get a reasonable titration value, like at least 15 to 20 to 30 cm cubed. That's why we need to dilute the vinegar in this question. It's too concentrated. All right, what else are points to note? This is a weak acid, strong base titration. So ethanoic acid is a weak acid, sodium hydroxide is a strong base, which means we have to choose our indicator to match. Now, I gave you an acronym the last day in the first video for strong acid, weak base, methyl orange, SOBMO. Okay, I don't know, it helped me to remember which one was which when I was doing leaving. So strong acid, weak base, methyl orange. Well, this one is weak acid, strong base, WASP, phenolphthalein. Doesn't work as well, but WASP, I suppose if you remember this one, then you know that this one's the opposite too. So SOBMO, and then remember, okay, the opposite of that, phenolphthalein. Okay, and the color change is pink to colorless because originally the phenolphthalein is in with the base. It's pink in a base. It's in the conical flask with the base, the sodium hydroxide, and then on the last drop at the end point, the solution turns from basic to acidic, and phenolphthalein is colorless in an acid. Now it says here, note, do not say clear. And the reason for this is some people say clear to mean colorless, but a solution can be blue and clear. Okay, so blue just means that it's a blue see-through solution, that there's no suspension, there's nothing, there's no precipitate floating in it. That means clear. But the solution is not colorless, it's blue. So that's not clear and colorless, not the same thing. You will not get the marks for saying clear. Notice the ratio here of the two reactants is 1:1. All right, so what we're going to do is we're going to jump into some questions. The first few are just pretty much recall knowledge that you guys have to know. So I'm going to tell you to have a look there at question 145, 146, pause the video and answer them now. It should be pretty straightforward. All right, so you should only be watching the video if you've tried to answer these. You should know at this stage that the standard solution means that you know the concentration. In this question, the ethanoic acid is what we're trying to find, so we must know the concentration of the NaOH, the sodium hydroxide, the base. How do you know? Well, what the standard means we know its concentration. We know the concentration, or we can work it out. All right, then it says describe the procedure followed to dilute the vinegar. Now, this is usually what 15 marks or so on the exam. That means you can't just say add water to the vinegar. It's much more complicated than that. It's much more detailed. You did a very specific process involving, okay, if you know how you did it, pause the video and write it out now. Okay, if you didn't know, if you can't remember how you did it, I'm going to give you some hints. So you should only be watching this if you can't remember at all. You would have used a pipette. You would have filled the pipette, describe how you fill the pipette. Then you would have transferred this vinegar to a volumetric flask and you would have made it up to 250. So you pipetted 25 centimeters cubed, added to a 250 volumetric, and then how do you top that up? Using as much detail as you can. Pause the video and write that out now. Bullet points is nice, keep it nice and concise. Okay, so you should only be watching if you've had a go at that. This is my answer. Okay, this is my answer, which would get you all of the marks. I have a heading here, just what we're doing, we're diluting vinegar. And then let's look at some of the points. So we're saying we measured the vinegar 25 cm cubed using a pipette. That's probably getting you 3 marks, the word pipette, measure using pipette. How do you fill a pipette? You fill it with a pipette filler. For safety, that's an important point as well, so it'll get you another 3 marks. How do you read the level in the pipette? You fill it until the bottom of the meniscus is on the graduation mark. Again, we're going to get 3 marks for that. How do we then transfer it to the volumetric flask? So you allow the pipette to drain under gravity. So in other words, you just let it flow out by itself into, and again, definitely you should mention what type of flask, a 250 volumetric flask. Going to get another 3 marks there. Okay, we're not finished yet because we haven't diluted it. We're going to top up carefully with deionized water. Make sure we mention deionized water, not standard tap water. And how do we read the level? We read it into the bottom of the meniscus is on the graduation mark. You could say at eye level. So I've actually forgotten something there. At eye level, reading at eye level. Okay, there's another 3 marks. And then stopper and invert 20 times is another 3 marks. Now, if you add them up, that's 18 marks. This question probably isn't going to be what 18. It might, on a year where the rest of the question is very hard, you might get 18 for this. But generally, it's going to be 12 or 15. So you need 4 to 5 good scoring points. But I would say you still need this level of detail, really, just to ensure that you do get points that do score the 3 marks. So as I can see, 15, 12, 18, it just depends on the year, okay? But the procedure is always the same. And you should still have the same level of detail, no matter how many marks it's worth, really, just to make sure that you are getting the marks. All right, so that is the procedural stuff, procedural questions done. And like I said, you can get a lot of the marks in the question by knowing this stuff. All right, so here it says below is a typical exam question. Use the technique from the previous question to identify the important information in the question. So in the previous question, I showed you how you should lay out these titration questions. If you remember how I did that, then you should go ahead and go ahead and set up your question now. As you can see, this here is the detail. This is the exam question. And here is the text that you're going to need, the information, and here is the balanced equation. So let's pause the video and see how far you can get by yourself there into writing out or setting up your question right. All right, so the first thing you got to do is, if you don't know, the first thing I recommend is to rewrite out this balanced equation. So do that now. Okay, so what you should have done is this CH3 COOH, CH3 COOH plus NaOH react to give CH3 COONA plus H2O. But the next thing I always ask your students to do is, well, this is an acid-base titration. So let's write down above them which one's the acid, which one's the base. Do that now. Okay, what you should have said is that this one is the acid, and this one here is the base. You should know that sodium hydroxide is a base. Even if you didn't know that this formula here is ethanoic acid, you should definitely know that this one is the base and then know that the other one is the acid. Okay, all right, so the next thing I always ask my students to do is use 2 arrows like this, one here and one here, and then the same on the base. Now, one of these arrows is for the volume used in each titration in liters, and the other one is for the concentration in moles per liter. And you will know only one of these in moles per liter, okay? So where do we get this information from? We get it from the text. All right, so I'm going to start reading the text here, and we're going to point out the important information. Now, the first thing I'm going to say to you is that this question has a little extra bit thrown in here. They don't actually give you the concentration of the base. They normally do, but not in this question. So you've always got to be on your heels. You've got to be thinking the problem through. Okay, remember, everyone is facing the same question. You've got to learn to solve these problems. And you do this by thinking your way through it, planning it out, planning what you actually have to do. All right, so let's have a look at what it says. It says to determine the concentration of ethanoic acid. So here I see some information about ethanoic acid. In a sample of vinegar, it says 25 centimeters cubed of vinegar were diluted to 250. So this was what we did before the titration. Okay, so this was the diluting of the vinegar. Now I'm going to write down in detail. What I want you to do is write down what is the concentration. It should be a number in another number, something in something dilution. What is the factor here? So pause the video and write down what type of dilution is this. All right, so at this stage, what I'm writing is this is a 1 in 10 dilution. 25 diluted to 250. So it's 10 times diluted, 1 in 10, which means that the original vinegar is going to be 10 times more concentrated. And I think that's going to be important later on. So I'm actually going to highlight that for myself. And again, this is good practice for you to get into. I recommend that maybe you get yourself a set of exam papers so you can practice doing this on paper, highlighting the important stuff. Rather than just doing it off the screen here, you should find this question in the exam papers and work like that. Okay. All right, and then they dilute, and then this diluted vinegar was titrated. Okay, so we can move on to the numbers here. It was titrated against a standard solution, which contained 1.2 grams sodium hydroxide in 500 centimeters cubed of solution. So they haven't given us a molarity, moles per liter. They're wanting us to do an extra step here. So before I can fill in this here, this number, the molarity of my solution, before I can do this, sorry, I need to work it out. Okay. So what I need to do is I need to work out my moles per liter. Okay. So what I'm going to do is I'm going to ask you if you can do this yourself. Pause the video. Go ahead and do this now. Okay. All right. If you couldn't do it, then we're going to do it together. The first thing we want to write down is what we have. We have 1.2 grams in 500 cm cubed, but always work in liters. So 500 centimeters cubed is half a liter or 0.5 liters. You should know that. So let's go ahead and write that down. Do some rough work. So I have a rough work section here. I've got 1.2 grams NaOH per in 0.5 liters. Now, what I want you to do is I want you to go from grams per liter to moles per liter. Okay, so we need our answer over here to be in a certain amount of moles. Moles of NaOH per liter. Now notice you've already got liters in the answer, so you don't need to actually do anything with that. What you need to do is turn grams into moles. So liters is good. Let's turn grams into moles. Pause the video and do this now. Okay, I've shown you how to do this loads of times using unit analysis. So let's turn grams of NaOH into moles of NaOH. So grams of NaOH will go on the bottom here and cancel out those ones. And moles of NaOH will go on the top to leave me moles of NaOH over here, which is good. All right. So what I want to know then is how many grams of NaOH is there in every 1 mole. So this is the molar mass. Pause the video, work out the molar mass of NaOH, and then do the calculation. Right, what you should have worked out is the molar mass of NaOH is 40. And when you do this sum, 1.2 over 0.5 times 1 over 40, what you should have get is 0.06 moles in every 1 liter. Finally, now we can write down how many moles per liter we have on molar, which is 0.06. 0.06. That was a lot of work just to get here. All right, and it does quite a lot of messing around in this question, but they've really tested you here. All right, it says now on average 18.75 cm cubed of the vinegar, the diluted vinegar. So this here is going to be our volume of diluted vinegar. And again, remember what we want to put in for the volume of vinegar, we want it in liters. So let's turn this here into liters and then write it down in our equation. Pause the video and do that now. Okay, what you should have got here is 0.01875 liters. This here is what we're trying to find. We don't know our concentration or molarity, so that's going to be an unknown. And then we need to know, well, how many liters of the base did we use each time? Well, it tells us here we used 25 cm cubed of sodium hydroxide. Okay, how do I know that those go together? Well, as you can see, they're close. Look, 25 centimeters cubed of this sodium hydroxide. So that's how much we used per titration. So go ahead and work out 25 cm cubed into liters. Again, I've done this loads of times in other videos. 0.025 liters is what we should have got. All right, so we've got a lot of information done there And now we need to go and figure out what way do they want us to do the questions in. Well, the first thing it asks us to do is work out the number of moles of sodium hydroxide in each 25 or each 0.025 liters, which we worked out a second ago, portion. Okay, so what we know is we know moles per liter at the minute, and we want to go to the number of moles. Okay, so let's, now that I've shown you what we're doing here, the planning. So the step one, we're going from moles NaOH per liter just to moles of NaOH. Okay, so let's work with the moles. Let's work with NaOH here. Just work with these values and work out the number of moles that was used per titration. Pause the video and do that now. Right, what you should have said is, okay, we know we have 0.06 molar, which is 0.06 moles per liter. So 0.06 moles per liter, 1 liter. We didn't use 1 liter, so we're going to cancel out the liters. How much did we use? We used 0.025. 0.025. And that will give us a number of moles. Look at the only unit that's left is moles. So that leaves us with moles in our answer, which is what we were asked to do. Here. Okay, so let's go ahead, stick down our calculator, 0.6 times by 35. And that should give you 1.5 by 10 to the minus 3 moles. 1.5 times 10 to the minus 3 moles. All right, so that's part 1 done. Probably worth 6 marks that. Okay, part 1. Let's look at part 2. Find the number of moles of ethanoic acid per centimeter cubed of dilute vinegar. All right, that's really sneaky, I think, there. Okay. All right, so let's work out what we want to do. We've got moles of NaOH. We've just worked that out. We can use our equation, 1-to-1 ratio, to work out our moles of CH3COOH. We can then go and work out our molarity, moles per liter of NaOH, oh sorry, CH3COOH. And then we've got to go to moles per cm cubed. Per cm cubed, because that's where it wants our answer in of the dilute vinegar. All right, so a few steps here, all right? If you, I'm going to leave that little plan there, what we need to do. So this is what we need to do in step 2, sorry. Go from moles of NaOH, what we just did, to moles of CH3COOH using the ratio, then find the moles per liter used in the titration of moles of CH3COOH, and then find the moles per centimeter cubed. All right, so I'm going to get you to pause the video and see, can you work your way through those problems? All right, so I'm going to show you how to do it. But again, like I said, this will be much more beneficial if you try this yourself. Okay. Well, we know the ratio is 1-to-1, so it's very easy to say if we had this many moles of NaOH, that's going to react with the same amount of moles of CH3COOH. So I'm going to write that down, 1.5 by 10 to the minus 3 moles of CH3COOH. That's pretty straightforward, 1-to-1 ratio. Then that means I had this many moles. But that many moles in each titration was in this amount of liters. Okay, that was our volume. So I'm going to put that, because remember I want my answer to be in moles per liter. So I'm going to put liters on the bottom here, and I'm going to write down how many liters that was for. It was for 0.01875. 0.01875 liters. Okay, so I'm going to go ahead and I'm going to stick that in, and we're going to find out how many moles per liter that is. So I'm going to work that out. Pause the video and do that now. Okay, and the answer that I'm getting here is 0.08. So 0.08 moles of CH3 COOH per 1 liter. Right, I'm going well, but I still don't have the final answer for this part because it asks, and this is really sneaky, I think. It's very rare you see them asking this, moles per centimeter cubed of dilute vinegar. Now, you probably get some of the marks for getting moles per liter, but that's not actually the final volume, the final thing that they asked you to do. So the next thing we want to do is basically end up, we've got moles already, which is good, but we don't want liters, we want cm cubed. So how can I get rid of liters and create cm cubed? Well, I need a conversion factor with liters and cm cubed. And I want liters to cancel, so I'll put it on the top and it can cancel here. And I want cm cubed left, so I'm going to put that on the bottom. So that gives me moles of CH3 over centimeters cubed. All right. So then the relationship here is that there are 1 liter for every 1,000 cm cubed. All right. So once we do this, we should have our answer in moles per cm cubed. So let's go ahead and do this part of the sum now. 0.08 over 1 times 1 over 1,000. And the answer I'm getting here is 8.5. No, not 8.5, sorry. No, 8 by 10 to the minus 5. And that is, of course, moles per 1 cm cubed. All right, so this here is the number of moles for the diluted vinegar in 1 cm cubed. Diluted vin. That's from the titration value. Okay, so that is that bit done. Okay. Wow. Okay, so that's a lot of work to get to here. So they're really testing your ability to think these problems through here. All right, let's look at part D then. It says find the concentration of ethanoic acid in the original vinegar. Let's go back and remind myself what type of dilution it was. It was 1 in 10, so it should be 10 times more concentrated in terms of moles per liter. Okay, so we're going to go D part 1 here. D part 1. Part 1. What do we need to go? We need to go moles per liter of the dilute vinegar to moles per liter of the concentrated vinegar. That's the plan here. So go back through your numbers and find the moles per liter of the dilute and then work out the moles per liter of the concentrate. This should be quite easy, I think. Pause the video and do this now. All right, so I'm going back to my values here and I'm being careful because remember, this isn't the number. This is moles per centimeter cubed, but we did find the moles per liter here earlier on in the calculation. It was 0.08 moles per liter. That's the concentration in moles per liter of the dilute. So I'm going to go ahead and write that here. 0.08 moles per 1 liter of the dilute. And I know it's 10 times more concentrated. I'm just going to go ahead and times this by 10. All right, pause the video and work it out. Yeah, what you should have got is 0.8 moles per liter is the concentrated. And that there is probably going to be, I think, 6 out of the 9 marks. So that's nice. That was easy. And then the last bit is going to be trickier, I think. So find it as a percentage weight per volume. All right. So I'm going to put a line under here for a second. And this is the concentrated vinegar in percentage weight per volume. Well, let's clarify what percentage weight per volume is. We've done this before. Percentage weight per volume. Let's write it down. What does this mean? Well, percent means per 100. That's what percent means. Weight means grams, and volume refers to centimeters cubed. So in other words, we want to know how many grams per 100 centimeters cubed. And remembering what 100 centimeters cubed is, it's 0.1 liter. So in other words, we want to find the grams per 0.1 liter of the concentrated vinegar. All right, so if you guys know how we would do that, you guys can go ahead and have a go at doing this now, okay? Let's plan it out. What do we know? We know here we've got the moles per liter. Mole per liter. What do we need to do? We need to find the moles in 0.1 liters. And then we need to find the grams in 0.1 liter. All right, pause the video and work your way through that now. All right, so the first thing I would do here is I would start by writing down what I already know. I know this guy here from this question, it's 0.8 moles in every 1 liter. So what I want to know is how many would that be if I had 0.1 liters? 0.1 liter, cancel out my liters. I get 0.8 times 0.1. That tells me I have 0.08 moles. So 0.08 moles for 0.1 liters. And I want to then find out how many grams that would be. So how would I go from grams to moles here? If you were stuck and I've helped you here, get to this far, pause the video and finish this up. All right, so what I want to know is mole for grams. And of course, it depends on the substance. The substance is CH3COOH. Okay, so I need to know how many grams there is for 1 mole of this. So pause the video and you'll have to work that out, the molar mass. All right, so the molar mass for CH3COOH is 60 grams in 1 mole. And now when we do this, we'll convert, of course, we will get rid of those moles and we'll be left with how many grams. All right, so let's go ahead and mark that out. 0.08 times by 60 over 1. And I'm getting answer of 4.8 grams. So that means there are 4.8 grams in a 0.1 liters, okay, which we can rewrite as 4.8%. So the solution of vinegar is 4.8% ethanoic acid. The rest of it is, so the other 95.2% is probably just water, all right? Again, that last one is worth 3 marks only. It's a lot of work for 3 marks, so you're probably only aiming for that if you're aiming for H1s, H2s. That's where you're really trying to get to the bottom of those marks. All right, 2 last little ones about the indicator. These are very important. Between the name of the indicator and the color change, you're talking 9 marks. So from memory, you can write down the name of the indicator and the color change that's seen. So pausing the video and having a go at them now. All right, I told you at the beginning, the indicator's name in this case is phenolphthalein. And they are actually pretty strict on the spelling of phenolphthalein. Noticing, I always tell my students to notice, we've got phenolph is the first word and phthalene is the second word. Phenolphthalein, I get them to say it like that. Phenolphthalein, so you have a better chance of spelling it. All right, what color change is seen in the experiment? Well, it begins in the base, so it's pink in the base, and it changes to colorless. So well done if you got the name and the color change, right? That will be what, 9 marks in your question. So almost 20% of the marks of this going for the name of the indicator and the color change. Calculation is difficult, guys. They're not always that difficult, but I said I picked the toughest one for us to work through together. So again, I recommend that you go and you find the other questions on the vinegar titration and you practice the hell out of them in your exam papers. That's why I advise you. That's the best way of getting good at these, and it has to become automatic the way you think your way through these problems. Anyone can make a little slip, a little mistake. Don't worry about getting 1 0 wrong the odd time. If you're like a 0 out or a decimal place out, that's called a slip, and you'll lose 1 mark for that. It's not going to mess up your whole, if that's the only little mistake you made and all the rest of it is done right, you're going to get most of the marks. So only worry if you're doing something really, really wrong. Okay, that's what I would say on them. All right, guys, that's the video on the vinegar titration. I would again advise now that while it's in your mind, find some other questions on vinegar titrations in the exam papers and practice them. That's it, guys. If you need me to do any specific questions, please leave a comment below. I'll see you and I can do a video for you. All right, see you in the next one.